Alright, this is just another random example. Alright, some of you, there's a few of you showing up and you must not be watching any videos. You have to do the procedure I'm telling you. You're not going to magically divine this. This is where things start to kick it up a notch. You can pay attention in class, but it's not going to cut it. Alright, you have to practice these. Problems we've already done, you need to go back and do them again with the solutions. And then you need to put the solutions away, do them yourself. Make sure you know what you're doing. Alright, so here we got a box being pulled at an angle of 30 degrees. Has a coefficient of kinetic friction of 0.5. What force would give us a constant velocity here? Alright, so as always, we have to draw a force diagram. Now you got to identify the forces acting on the box. On the box. Watch the videos. On the box. Alright, so forces acting on the box. We have gravity acting on the box. Negative 600 newtons. Alright, definitely. We have this applied force. 30 degrees. Alright, cool. We have normal force still, because it's on the ground. People forget that sometimes because that applied force going in an angle. We have a frictional force. Alright, this is actually a pretty easy problem. Now, at the end of the day, when all said and done, the key here is the fact that the force, you can write this two ways. You can either write it as the sum of the forces in the x direction must equal 0, or you can write it as F net x equals 0. You can write it as sum of the forces in the y direction equals 0. F net y equals 0. Alright, you can write it either way. Doesn't matter. They mean the same thing. At one point I preferred the sum of the forces. Lately I prefer the net force, F net, so you know what that means. So you get to learn what that means. So, all the forces in the acting in the x direction must add up to 0. So that means the x component of this y force plus the force of friction must equal 0. Okay? For the y direction, that means Fn, normal force holding it up, plus the y component of the applied force plus the gravitational force must equal 0. Now, you might be saying, Harmon, aren't some of those negative? Shouldn't you make them negative? Yes, we are going to make them negative. However, it is the sum of the forces. Alright? You need to remember that, because kids will make sign errors sometimes. Alright? So, Fy is going up. Fx is this component. So that's Fy and Fx. We have to figure out what those are. Even though we don't know F, it doesn't matter. Because right now, okay, I know the equation for force of friction, right? So let's put that in. Let's put in what the force of friction is. It's going to be negative, right? So it's going to be like plus negative mu Fn. Do we usually write it like this? No. We usually just write it as minus mu Fn, right? We usually don't write it plus with the parentheses. We usually just jump right to this step. In fact, I pretty much always just jump to this step. Force x component minus this. Anytime I start putting in variables for one of these original summation ones, I put the sign on it. Alright, over here for Fg, I can put the number in there, right? Or I can put in negative mg. Sometimes it's better just to put in negative mg. Right? It's better to solve for variables. In fact, I think we will solve for variables first here, and then put in numbers. So the x component of the applied force minus mu Fn minus the magnitude of the force of friction must equal 0. The normal force plus the y component of the applied force minus the magnitude of the gravitational force must equal 0. But we have way too many unknowns here, right? M's a known, G's a known, Fy is unknown, Fn's unknown, Fn's unknown, Fx is unknown. So you have 1, 2, 3 unknowns, 2 equations, not good. So, fx and fy we need to write in terms of f. They can each be written in terms of f. That would eliminate an unknown. So, I usually do that right in the beginning. Some of you are resisting this, right? So, right in the beginning I write fx equals f times the cos of 30 degrees. I'm going to call it theta for now, because I'm going to solve this all in terms of variables, so you see how that's done. Fy equals f sine of theta. Alright? So, now, when we put them in here, we have to make note of whether or not they're negative or positive. In this case, these components, since it's angled forces in this quadrant, they're both positive. Fy is positive, fx is positive. So now in here I put f cos of theta minus mu fn equals 0. Over here I put fn plus f sine theta minus mg equals 0. Now, yeah, you know what? A lot of you want to jump ahead here and just kind of say, oh yeah, look, fn equals fg. But no, really it doesn't. It's fn and the y component have to equal mg. So you got to be careful there. But now what you see is we only have 2 unknowns, f and fn. Theta, mg, mu, those are all known. So this is just algebra at this point. I solve one of them for fn, and I plug it into the other one. So I'm going to solve for fn. Alright, so f cos theta equals mu fn. Alright, divide both sides by mu. Alright, so now I have fn equals f cos theta over mu. That's going to get plugged in over here, right here. So I end up with f cos theta over mu. And if there was a negative sign in front of it, for some reason, if I solved for a variable over here and I had its magnitude, you know, how big that force is, and I was going to plug it in over here, but I knew it had to be negative, I would make it negative. All right. Plus the y component, f sine theta minus mg equals 0. All right. So at this point now, I'm solving for f. So I'm going to bring the mg to the right, and I'm going to factor the f out in front. Or, as somebody today said, I'm going to de-distribute the f, right? I'm going to de-distribute the f. I liked that. So on this side, we're going to end up with f cos theta over mu plus sine theta, you need to put parentheses around that, equals mg. All right, so I'm solving it in terms of variables. We're in the glare zone down here. All right, we're in the glare zone. So now I'm gonna erase a bit of this, right, that I've done. You guys can pause it in the video and rewind and look at it, but I'm gonna erase a lot of what we've done here. All right, so I divide this side by mg. So I end up with f equals mg over cos theta over mu plus sine theta. I guess you could bring the mu upstairs, right? If you multiply by mu over mu, but then you'd have mu sine theta here. But now you'd pretty much just plug everything in. You could get the number. So F would be, you know, the mass 60 kilograms, G 9.8 newtons per kilogram. You know, you can put a 9.8 if you want, because we only are doing it once. Don't put a negative sign on that, right? F, we're finding the magnitude of F. That doesn't even have a sign, right? It has an angle. It doesn't have a sign. So don't put, G is not negative 9.8. It's 9.8. You make it negative depending on which direction you're putting it in. Cos of 30 over 0.5 plus sine of 30. That's going to equal something, all right? We'll see if it makes kind of sense. 60 times 9.8 is 588 divided by cos of 30 divided by 0.5 plus, oops, I'm going to need, no, I won't need a parenthesis, times sine of 30. And I got about 263 for the force angle, right? Yeah, so there you go. Looks good. And there's really no other good way to do it. That's probably, that seems reasonable. 263. So that means the force of friction is 263. So that means the normal force is 263 divided by 0.5. So the normal force is about 526, right? That's less than 600, so that's good. So that means the vertical component of this is, the difference. So that seems like that's probably about right. Anyway, maybe I made a math error. Something seems a little bit off, but oh yeah, you know what? I think that is off. I think I need another parenthesis there. Man, it's the second time No, that should be good. That should be the right number of parentheses. Anyhow, that time I got 235. No. Okay. Anyhow, we'll let me try that one more time. I'll check that number and get back to you. All right. Sorry, I misspoke a minute ago. 263 is F. So that doesn't mean the force of friction is 263. I'd have to find the x component of that, then find the force of friction, then find it. But we are in the right ballpark, so I'm going to say that answer is probably right. It'd be time to move on. So just to kind of recap, again, anytime any force setup, your step 1 is the force diagram. Step 2, so step 1, force diagram. Step 2, any angled vectors, break them into their components, even if you don't know the numbers. Still write this down, because when you go to Newton's second law, which has now been erased, you're going to have to put in those components for fx, fy, f1x, f1y, and so on. Okay, so you got to put those in there. These problems are very hard to just like magically think of in your head and try to say, okay, that force has to be equal to this force, and that's going to be the answer. No, they require the process. They require the steps. You have to do it. You just have to. Please follow my framework. Force diagram. Angled vectors into components. Some of the forces in the x has to be 0. Some of the forces in the y has to be 0. Set up the Newton's second law equations. Be careful of the signs, right? Like that's the magnitude of the force. F cosine theta is the magnitude of this here. If F was going this way, the x component of the force would have to be negative F cos theta. So you have to put the sign on these things. Remember that. All right, important. Force diagram, components, Newton's second law. Be careful with your signs. Do the algebra. And yes, sometimes it's tricky. Sometimes it's a pain. It's college level physics, people. Buck up.